Hello, we are now going to be talking about rational functions, and here is the graph of the rational function. This is the parent function, which is equal to y over the input of x. So here's a couple of key ideas that I want you to remember as we work with this function. We will be using what we call asymptotes. Now, an asymptote is a line on the coordinate plane that a curve approaches but does not touch. So in this case, the graph is this curved line. It is approaching y equals 0, but it will never touch it. It just looks like it's touching it. And here the asymptote would be x equals 0, because as we can see, this portion of the curve is approaching it but will not touch it. So a couple of different asymptotes that we need to look at. We need to look at a vertical asymptote of a rational function, and it is the vertical line on the coordinate plane that the function approaches as y goes to positive or negative infinity. So here you see the arrows on the end of the y-axis. Well, they're going towards positive infinity or negative infinity. Here, the next is a horizontal asymptote, and the horizontal asymptote of a rational function is a horizontal line on the coordinate plane that the function approaches as x goes towards positive or negative infinity. So as the x-axis continues left or the x-axis continues right, as the curve approaches that line is called the horizontal asymptote. Now I want you to remember, when you're writing the equation of that asymptote, the vertical would be x is equal to whatever the number is. I'm just going to use a. And the horizontal asymptote would be written as y is equal to whatever the number a. Now we also have a term that we're going to be using called excluded value. The definition of that is basically a value that's left out. We know that we can never divide by 0, and we see that this is a fraction. So we can see that this bar here, it makes the equation look like a fraction. It also means division, and we can never divide by 0. Where we divide by 0 is what we consider undefined. So whatever makes this denominator 0, if we're adding or subtracting, and we come out with 0, at that part or at that number, the function is undefined. So we use that excluded value also as our vertical asymptote. It'll be as vertical asymptote where we know we have to answer it as x equals whatever number, or if it's asked as the excluded value, we're just going to say what the excluded value is. It is not the equation of a line, so be very careful with that. So for a rational function of the form y is equal to a over x minus b plus c, this is the equation we use for transformations. And what we know is that here in the numerator is how much the function either stretches or compresses. C is going to be your horizontal asymptote. And here in the denominator is going to be your vertical asymptote. And this is what we will be using when we are actually doing transformations. Now, a couple of other things you need to know. The domain of a rational function is all possible x values except the vertical asymptote. So when we write the domain, we write from negative infinity to whatever number is being excluded, or to where the function is undefined. And then we have this little u, we call it union. and then to the right, so 0 to infinity. Now, the parent function, this is the domain. And what we're really saying is all of our possible x values are from negative infinity to 0 or 0 to positive infinity. The same thing with the range. The range of a rational function includes all possible y values except the horizontal asymptote. So the range of the parent function is negative infinity to 0 or union 0 to positive infinity. So let's go ahead and test a couple of these out. So here we have our first example. We're going to look at the graph, which we see what is the equation of the vertical asymptote. So remember, the vertical asymptote is the curve as it approaches the y-axis. So you're looking up and you're looking down. So here, our vertical asymptote would be x is equal to 0. Now, our domain on this then would be, we can go from negative infinity to 0 or 0 to positive infinity. Now look at our range. Our range is a little bit different. Now I know it didn't ask for this, but I want you to get used to seeing it and thinking about it. Here is our horizontal asymptote. Now we can see that the curve is approaching where I have the yellow, which is negative 5. So then our range would be from negative infinity to negative 5 or negative 5 to positive infinity. And the equation, well, we didn't have any left or right movement, so it'd just be 1 over x, but the function did drop down 5, so we would say subtract 5. Let's move on to the next one. What is the equation of the horizontal asymptote? So horizontal we know is y equals, and we are looking here because the line runs horizontally. And if we look at this, it's 1, 2, so it'd be y is equal to 2. But again, I want you to get used to seeing the domain and the range and thinking about the equation. My line was a little off there. All right, so the domain here would be all possible x values from negative infinity to 2 or 2 to positive infinity. Our range is negative infinity, also up to 2. I think that's 2. Yeah. Or 2 to infinity. And the equation, all right, so was there a left or right movement? Yes, there was. And just like all of our other functions, we write everything opposite. So here, it's moved to the right. So think about, what does it have to do to get back to 0? Well, we have to subtract 2. And you can also think about, if I put x minus 2 equal to 0, I'm asking what is the x value? Well, the x value would be 2. And then our shift up would be positive 2. So this is the equation of this rational function. Let's move on. What is the excluded value of this function? So here we're just saying, okay, what number do we not include? And please forgive me, I'm trying to see this and I'm looking on the screen, so. And I keep missing it every time, don't I? Okay. So you notice here, this is negative 5. Well, if I take my pen and I run up, I see that my excluded value isn't at negative 5, it's right over. So our excluded value is actually negative 6. Our domain is all possible values from negative infinity to negative 6 or negative 6 to positive infinity. Our range, will notice that, excuse me for reaching over there. Our asymptote is at y is equal to 0, our horizontal asymptote that is. So our range would be negative infinity to 0 or 0 to positive infinity. The equation, there was a left-right movement, so think opposite. It moved left, so we're going to say x plus 6. And there was no up or down movement, so we can just leave it as this. Moving on, we have, look at this graph. What are the equations of the horizontal and vertical asymptotes? So horizontal, we can see that the curve is approaching y equals 0. So we're going to say horizontal asymptote is y is equal to 0. The vertical asymptote, however, is x is equal to I think I just said that backwards. I did. Ooh. Okay, so the vertical asymptote is x is equal to 0. Horizontal asymptote is y is equal to negative 6. So I'm going to put a negative there. Put it like that. Please excuse me, I don't know why I said that. So our domain then is all possible x values, so from negative infinity to 0 or 0 to positive infinity. We're looking this way to the blue line, skip over the blue line and continue. Our range is negative infinity to negative 6, union negative 6 to positive infinity. And again, we did not have any left or right movement, so we're going to write the parent function, but we saw that our function did drop 6. Let's go ahead and look at this particular function. Now this time, what we did was, I included this graph, and if you notice, the graph has the parent function on it. So I'd like to go ahead and graph this to see what it looks like. So first of all, let's answer the question, what is the excluded value? Well, the excluded value comes from the denominator. So x plus 3 is equal to 0. Subtract 3 from both sides. X is equal to negative 3. So the excluded value is just negative 3. That would be your answer. However, let's just say we wanted to sketch this function. Well, we have the parent function here, and what we know is that the function, according to here, drop down 8. And what we also know is that the function moved left or shifted left 3. So 1, 2, 3. Now, there are times when we do have a reflection. We're not going to talk about reflections right now, but this could be reflected. Right now, what we know is that it's positive, so it continues to look like the parent function, where you have the curve in quadrant 1 and the curve in quadrant 3. So what we're going to do is just going to sketch, don't go like that. I'm going to sketch like this, and then we're going to sketch like this. So notice again, our curves have to approach the asymptotes, but cannot go past the asymptotes. So our domain here would be from infinity to negative 3, union negative 3 to positive infinity. And our range would be from negative infinity to negative 8 or negative 8. That's supposed to be 8, sorry, to positive infinity. And let's go ahead and look at this one. What are the equations of the horizontal and vertical asymptote? So here, our horizontal asymptote, let's do that one first, is y equals 0 because the function is not moving it's not moving up or down. And we know that because there's no plus or minus number here. But what we also know is that the vertical asymptote, here we have x plus 1, so we know that the vertical asymptote is x is equal to -1. So let's go ahead and we know our horizontal asymptote is here. Our vertical asymptote is at x equals -1. And so as you can see, we're just going to move a little bit to the left here, and a little bit to the left here. And that's what that would be. Our domain would be from -infinity to -1, or -1 to +infinity. And our range would be from -infinity to 0, or 0 to +infinity. All right, now you go ahead and take your turn. All right, so here are the answers to the your turn. Make sure that you really understood what was going on. If you didn't, please ask questions. I'd be more than happy to help you. See you next time.